Hi guys, so today we're doing organic chemistry again, but today we're going to take a look at the applications of organic chemistry. So we're extending the idea that we got from our last videos of homologous series. So after homologous series, now we are going to do reactions. So this is one of the real life applications of organic chemistry, so you can see that it's very useful. So today we're going to take a look at combustion and esterification reactions. Okay, so these are the two important reactions we encounter daily. So the reason we're studying them is because they are reactions that you encounter daily. Some are just happening naturally, some are happening like during the burning of fossil fuel and other stuff, but you don't realize them. Hydrocarbons are one of the most important energy resources on earth. Remember, without the hydrocarbons we can have a petrol. So if you don't have a petrol, actually most of the machines are not going to operate, right? We are going to focus on the combustions of alkane. So we have a different kind of combustion where because even the burning of these of a petrol, it does contain some toxic elements or compounds, but we're not going to focus on them. We're just going to focus on the combustion of alkanes only. So here is the first one, and remember that the reason we're focusing on this is because this is the exam-based questions. You are going to get combustions of alkanes. So the equation formula of that, it's alkane plus O2 for the reactants, and it gives you carbon dioxide and water. So that is fixed. It's like you must have any kind of alkane, right? So we add that with oxygen, and then you get carbon dioxide plus water. So these will never change. So always, if you are given any kind of alkane, remember that alkane has a suffix of ane. So you are going to have a methane, ethane, propane, butane, pentane, hexane, heptane. All of those things are the alkane octanes. So we are going to take a look at those kind of reactions where we take one alkane, we add this, or we burn it in the excess of oxygen. This is the excess of oxygen, and we get the carbon dioxide and water, which these are the two things that when a car it's moving, it's happening this kind of reaction, because you will get the carbon dioxide from the exhaust, and you get some sort of water also there. Okay, but there are some toxic compounds that we are not considering here. We're just considering the carbon dioxide and water. Okay, so let's move forward. Recall that the general formula of alkane is given by this. This was the general formula of alkane, was CnH2n plus 2. So if I have a 2 number of carbons, how many hydrogens will I have? You put 2 here, it's going to be 6. Alright, so this is going to be the general formula. So to balance this equation, there are some of the steps that we must follow. So let's take a look at those steps. This is still the combustion that we talked about. And then here we must follow some rules to balance the combustion reaction of alkane. Okay, so first you must balance the carbon atoms. If you don't follow these steps, please, you have to follow them, because if you don't follow them, you're going to stuck at some point. So you must balance the carbon atoms. Secondly, you must balance the hydrogen atoms, and then lastly you must balance the oxygen atoms. Okay, so to do that, to show that, let's complete this example. Complete the following reaction. So here we have these. How many carbons do we have there? 4. And how many oxygen? Just 2 of them. Okay, so we call this element here according to our naming, the IUPAC name of this. Remember that we did the naming. If you don't recall, please watch my last videos where I was naming this alkanes and alkene and alkynes. Okay, so this is going to be, since it has 4 carbons, remember that if it has 4, that means the prefix is going to be but. So since the suffix is ane, this is going to be butane. It's going to be butane because the suffix is ane. So we call that This is a butane burning in the excess of oxygen. That's when you put this equation in weights. It's a butane burning in the excess of oxygen. So obviously we know that if that's a C4H10 plus O2, it's going to give you carbon dioxide. Carbon dioxide is a must plus water. So it doesn't change, always give you like that. So now what we are left with is to balance it. If you are given this, you don't even have to think about the products. They're always like that. Okay, so let's balance. First we balance the carbon. We have 4 here, so we put 2 here in order to have 4. All right, we balance the hydrogen. We have 10 hydrogens here, so we have to put 5 here in order to have 10. Okay, so we come to oxygen. So oxygen, we are going to have this, which is 4, and plus this, which is going to be 4 plus 5, which is 9. So we are going to have 9 oxygen on the other side. So to balance that, it's going to be hard. Why? Because here you have 4 plus 5, which is 9. So this is an even number. It's an odd number. This is an odd number, and here you have 2. So this actually is an even number. So you can balance the odd number and the even number. So you can balance odd and odd, or you can balance even and even. So here the number of oxygens add up to odd, and then here the number of oxygen add up to even. So what you must do, you have to change one. You have to change one to be even, or change one to be odd. So can you change even to be odd? Nope. The answer is no. You can't change. You can't change even to be odd, but you can change odd to be even. All right. So let's take a look of how can we do that. Okay. So since you can't balance these two, we go back and start again. So when you start again, you put 2 here. Now, since it was 1 first, you put 2 here. You are balancing the carbon first. So you put 2 there, and you're going to put here, since it was 2, now you're going to put, you see here now you have a C2C4, so that means this is 8. So how many hydrogens you need, carbons you need? 8 of them. All right, so also in here it's going to change. So when it changed there, when it's changed, since now you have 20 hydrogens, so here you put 10 to get the 20. All right, so now let's check for the oxygen. For the oxygen here you have an even number, which is 2, and then this one is 2 times 8, which is 16, and then this is 10 times, what is this, times 1 here, which is 10. So it's going to give you 26. So both of them are even and even, and then you can, this 26 is even, and then you can balance that. So which number can you put here to give you 26? It's 13. So you put 13 here, you get 26. So that's a balanced equation. So this is a balanced equation. It's a balanced equation. All right, so I hope you see that. Try to pause the video and try this one, and try to balance this. Try to balance this one here. Pause the video and try to balance, please. Now, okay, so if you tried it, I hope that you got this, because when you try to balance this, you're going to get the same problem as the previous one. So that's why here we put a 2 in order to make the oxygen to be even. So when you take this 16, you multiply by this, you are going to get 32. Then you take these 18, you add there, so actually you have 32 plus 18, which is going to give you 50, right? So when you take 25, you multiply by 50 also, so the oxygen is balanced already. So you can do the same thing for the carbon. If you take this, you multiply by this, you get 16. Then here, if you take this, you multiply by 2, this, you get 16, because here is just 16 times 1. And then you can do the same thing to the hydrogen. The hydrogen is here, it's 18. So you take this, you multiply by there, you get this 18 times 2, you get 36. then you take this, you multiply by that, you get 36 also. Okay, so this is how to balance the combustion reaction. Always follow these steps, you will never get lost. So let's do the last one. So the last one is going to be the esterification reaction, since we said we are going to talk about these two. So this one kind of reaction that's important because it's formed by combining the carboxylic acid and an alcohol. So when you combine the two, you get these esters. So the esters, they have their certain characteristics, there are certain catalysts, and we all have to learn about those things. So here, these are organic compounds which form as a result of reaction of carboxylic acid and alcohol, and as I told you, so when you combine these carboxylic acid and alcohol, you get an ester. So from this reaction, for this reaction to happen fast, we add sulfuric acid. So sulfuric acid is going to act as a catalyst. Remember, the function of catalyst from grade 11 is to make the reaction, speed up the reaction, Okay, so esters have a pleasant characteristic smell, so they smell nice, e.g. of flowers, fruits, and etc. So fruits, we're talking about bananas, those are the fruits that smell nice, but fresh ones, not rotten ones. If they are rotten, now the alcohol are no longer esters. So these are the natural esters, fruits and flowers. These are natural esters. So let's take a look how an ester is going to be formed. Okay, so the reaction formula for the ester is given by this. It's alcohol, carboxylic acid in the presence of this. So this is a catalyst, don't worry about that. This is a catalyst, and it gives you the alkyl alkanoate, which is what we call an ester. It gives you alkyl alkanoate, plus water. So we are going to take a look of how those products are formed. So remember that we said that R prime is going to be always the carbon that carries the functional group. So for alcohol, this is the functional group, if you remember from our last video. So this is the functional group for alcohol, and it's given by this, right? So we add that with this, which this is a carboxylic acid we did in our last video. It's going to be RC double bond, and you have this here. So this here means that it's a carbon, another carbon, or it's a carbon chain. You can add more and add more and add more, but this is a carbon that has the functional group. This is a functional group structure, and then you have to add these two. You have to add them in the presence of sulfuric acid. So never and ever forget this, because this is important, and you will get something like this. Okay, so you have RC double bond O R prime. You see it's here, RCOO R prime plus H2O. So that's water. Then now let's check how this is formed. So here there's a process called condensation that takes this here. We extract this, and here on this one we extract this, and to get water, let me write this water in another form to get this. So we call that process this as condensation. So to get this water, you extract hydrogen here, and you extract hydroxyl. So this is hydrogen, and you extract hydroxyl from carboxylic acid. So in order to get water, so when you extract the two, let's take a look at this one here. You are left with RC double bond, right? RC double bond, which is this one here. You are left with RC double bond of oxygen, RC double bond of oxygen is this one here, RC double bond of oxygen, and one bond that was going down, which is this one now here, right? So, and for this one, when you extract hydrogen, you are left with OR prime, so which is here, OR prime. So that's how an ester is formed. It's formed by the combination of the carboxylic acid and alcohol. So when we give it a name, you're going to name it, this alkyl here is going to come from here, from alcohol, and this alkanoate is going to come from the carboxylic acid. It's going to come from this one here, the carboxylic acid. So when you name it, you count the number of carbons that are in the alcohol. So if it's a ethanol, that means it has 2 carbons, and this prefix here is going to be ethyl. It's the same way you name the branches. So if this was propanol, it's going to be propyl. Same way you name, and this is going to be methyl. So if our alcohol has 1 carbon, it's going to be the first name of ester is going to be methyl. If all of these names are coming from alcohol, so this is a prefix name from alcohol. From alcohol, prefix name. Of esters. So the suffix name, we're going to take those things from we're going to take them from carboxylic acid. So if we have like ethanoic acid, that means the suffix name is going to be ether. It's going to end with ethanoate. It's going to be ethanoate. So if you have 3 carbons from the carboxylic acid, which is going to be propanoic acid, and then the ester is going to be, the suffix is going to be propanoate. So we are taking the suffix, these are going to be the suffix. So these suffix are coming from the carboxylic acid. Suffix name, this is a suffix name, and this is a prefix name. Suffix name, so we have to tell them where these are coming from. These are coming from the carboxylic acid. Coming from the carboxylic acid. From carboxylic acid. It's where we get these things. Okay, so now let's go and do the actual example where we show how these things are happening. Okay, so since we said that we're going to get from here, it's R prime, this one here. Let me just copy the whole of this. Okay. Let me copy it and paste it here. Okay, so let's follow this structure to give us age. Remember that you have also water here. So let's follow this pattern to get the actual reaction. So let's check an example here, since I think I have an example. Okay, using the structural formula, write down the balanced equation of the esterification reaction that happened between ethanol and propanoic acid in the presence of sulfuric acid. So we're going to take ethanol plus propanoic acid in the presence of sulfuric acid. So we have ethanol, right? We have ethanol. We add this plus propanoic acid. Okay, acid in the presence of sulfuric acid, and we are going to get, remember that we said that the suffix is coming from here, So this was ethanol, so we're going to get ethyl already. We're going to get an ethyl. We're going to get ethyl. And then since the suffix is coming from here, it was propanoic acid, so we're going to get ethyl propanoate plus water. So these are just the names, are just IUPAC names. So now what we must do, we must draw the structure as the instructed us. So the ethanol, remember that as from my previous video I showed you how to draw the structures of ethanol, how to draw the structure of propanoic acid, and so on. So if you haven't checked them, please go back and check those videos. Okay, so here we are going to have 2 carbons, and then the hydroxyl functional group is in the first carbon, something like this. You're going to have this for this one, and we add. So for the propanoic acid, we're going to have 1, 2, 3. Since it's prop means 3. So in our last carbon you have a double bond, and you have this hydroxyl here, right? So here you have hydrogen, hydrogen. This is propanoic acid, and then you add. Here remember that you must have your sulfuric acid as a catalyst, as I told you. Okay, so after that, ethyl propanoate. Remember that the first part, this one, is this part here, is the last part. So the last part in here is this one here, is the first part. So it's just vice versa. The structure is vice versa of the name. Okay, so now we're going to start with this part of propanoate, so which is going to be the part of carboxylic acid. So let's take our carboxylic acid. Our carboxylic acid was like this. So we're going to have 1, 2, 3. So on the third carbon you had a double bond, right? Double bond is here, and we removed this, and we removed this thing also here. We removed those 2. Where are they? Are here. We got water from them. Okay, so this you just add as the way it is, and here is going to be hydrogen. So this is the carboxylic part, which is this, which gives us the propanoate. So you go to the second part. So the second part is easy also. You just add this part here. So to add that part, you give this as a SO, because it's this O here. You join it using this O and 2 carbons, and then carbon, which these things are coming from alcohol, right? And then you add plus water. Just don't have a space for that. So this is how you can draw this structure, the balanced equation, structural formula, the balanced structural formula or balanced equation of this thing by using this thing. So you see, since here they said balanced equation for esterification reaction that happened between ethanol and propanoic acid. So this is going to be the answer, and then you're done. You just have to know how to form the name. Okay, so thanks for watching my videos, and please keep watching them in order to ace your classes, and also don't forget to subscribe.